This is kind of, I start off with this because the properties, listen carefully, the properties you use here, you don't use them when you're dealing with parallel lines. This doesn't tell us whether or not lines are parallel, these properties. So at the very top here, this is always true. These ones are always true. The fact that a straight angle is equal to 180, correct? That's always true. It doesn't matter if lines are parallel or not. Is it a bit small? Well, that's kind of what your study sheet will look like, right? So this one is always true. Whether angles are complementary, right? So complementary. So this one, 1, 2, and then this one, sum of triangles is equal to 180. That's always going to be true, right? Those three angles always add up to 180. And sum of four-sided is 360. That's always going to be true. And what else? There's one more. Vertically opposite angles are always going to be equal to each other. So that's this one, right? This one is going to be equal to that one. So 1, 2, 3, 4, 5 properties. These 5 properties are always true, even before we started this unit. So you cannot use these. Do you see parallel lines anywhere on these ones? You can't use these ones to justify whether or not lines are parallel. Will you remember that? You can't use these ones. So if you're like, hey, look, vertically opposite angles are equal, lines are parallel. No, it doesn't help. Try again. These ones, though, listen carefully, these ones are awesome to find missing angles if you're stuck. These ones are awesome because we don't need lines to be parallel to be tapping into these. All right? I hope that makes sense. So let's use these ones perhaps to solve what's happening here. So A, I guess you don't have to start with A, but if you did, if you started here, you would just go 180 minus 115. That's 65, yeah? Yes. And I used straight, right? Straight angle is equal to 180 there. B, I can use vertically opposite. 115, vertically opposite. Okay. Another dead giveaway is that everything is touching here, right? If angles are touching, then they're not going to be part of the parallel line family, okay? That's usually another giveaway. C, you get the drill. C is also, you could use straight angle, or you could use vertically opposite to A, whatever you want. So it just fills in. I'm not going to do all of this because I think you guys should be able to do it at this point, or do you have a particular question on this one? Yes? Which one? D? This one? How did I find that one? I have to think. I don't have the key in front of me, so I'm just going to be careful. If this is 90 and this is 73, okay? Do you see the straight line right here? And you've got the hat like this. So I basically went 180 minus 73 minus 90. This is 90. That gives me D. Does that make sense? Okay. Yeah. So sometimes just zoom out if you're like, I'm stuck, zoom out. Try again. This one here you wanted me to do, right? The bottom one here. I had a few students ask me for that. Sure. This one is this one over here, just a little different version. But anyways, how do you want to start? Notice that B and C they're touching this angle. So here, you're going to use the ones I just talked about. They're all touching each other. So you could do B. You could do that one first if you'd like. And that is 140. We know that already. And I just use straight angle. is equal to 180. However, do you see parallel lines here? You should notice, okay, markings. So there could be a chance that I could jump this way if I wanted to, but I'm just gonna stick to this part right here. For angle C here, I'm gonna do that one next. So if this helps you, you fill in the angle, right? This is 140, and these are what? Vertically opposite. So I can go 140 here, and just say if I want to use something else, I can use vertically opposite here. Instead of using, you could have used straight angle again here, right? This is a straight line. You get the same answer. That's really what we're after here. Angle D, let's do that one. Or A, can you do A right now? Maybe some of you did. So this is maybe the frustrating, I find that beautiful, that is different ways of doing that. But yeah, maybe you saw, oh, this is 110. What's this one? 110. Do you have a small triangle here? Yeah, so you could use sum of 180, sum of triangle to get this one. Or is there a way to get D first? This one. Yeah. Can I use B to find D in this case? You might think so, but they're not, right? This one is, it looks like alternate exterior, but this one is inside, this one is outside. So if you wanted to use alternate exterior, you would find this. But what do we know about these two here? They're both inside the parallel lines, right? These are CIAs. So you could have found that first. That's my third, let's say. And I'm just going to say that angle D is going to be 180 minus whatever C is. So it's 180 minus 140. So that's 40 degrees. Okay? How else could you have found this? Using 110 and A, right. So if you somehow figured out what this was, and then you have this one as well, you can use sum of triangle to find that one. Anything else? Any other property I could have used to solve for D? What is D and this one here? What are these two angles? Corresponding, right? So no matter how you go about it, it's 40, right? No matter how you do it. I'm just going to go 40 here. And I use CIAs in my case, okay? Or you could have used sum of triangle, or you could have used corresponding. So it gets kind of messy, but they all serve the same purpose. And last but not least, I'm going to do A here at the very end. Now that I know that this is 40, I'm just going to use these to get me that, because I see a triangle here as well. So I'm just going to use sum of triangle is equal to 180. I'm just going to go 180 minus 110 minus 40. And that is 30, right? So that's 30 degrees there. Could you have used anything other than sum of triangle to solve for this one? No. There's nothing else. Like, you cannot use the 4. I don't know if you know what I mean with the 4. There's corresponding. There's alternate exterior, alternate interior, and CIAs, right? These are only going to be if you have parallel lines and a transversal connecting. Only then can use it. So there's nothing you can do here. You have to use sum of triangle either here or sum of triangle out here. Okay. All right. Which other one? Page 22. Which one here? Yeah. The last two? The last one? The last two? Okay. We'll do both. So just pay attention and Yeah, highlighters are maybe really good idea for some of you to like see what happened when, because when everything is filled in, it's very hard to see what happened. Okay. Remember, our line's parallel in this scenario here. Yes, I can use the 4. I can use the 4. How many transversals are you going to focus on at a time? 1. So pick this one or this one. It doesn't matter. If you pick this one, you got to eliminate the noise, right? You got to almost remove everything else. What would be 38 and why? Yeah, so you can alternate interior, right? You kind of want to find a number and see how can I use that number to bring stuff over to the other side. Okay, so that's my strategy here. So I'm going to start with y. That's what I put a number 1 there. It's 38, and I use alternate interior. Angles are congruent. Okay. Next, why don't I pick the other transversal, see what happens there. So I see the number here, and I travel along that transversal, right? And then there's a number there. What are those? Also alternate interior. So W is my second choice here. Just like Canada yesterday, right? Big W. Did you watch hockey? I don't know if you watch hockey. We beat the U.S. 32. Okay, we got it. Now we're going to focus on these here. So careful. Do not use any of the 4 musketeers. Don't use them here because there's no parallel line here, correct? You know what I mean? So you kind of have to ignore it at first. Just ignore them. And then once you have these, right, you can actually write down 32 here, and then you can use sum of triangle there. So I'll do x third. I'll use just 180 minus 38 minus 32. This adds up to 70, right? Yeah, 70, so 110. And I use sum of triangle is equal to 180. So this is 110. And then z, we can do that last. I will use straight angle here. Oh, Mr. Erickson, it's maybe corresponding, isn't it? Kind of looks corresponding to me, right? No, there's no parallel line here anywhere, so don't be using those. They're touching each other though. So 180 minus x, that's 180 minus 110. So this is 70 degrees. And I use straight angle. Yikes. Straight angle is equal to 180. That's what it says there. Okay. So 70. Does that help? Yeah. Okay. One more thing. You realize this is 70. This is 110, right? Do you notice that it doesn't at all match any of these ones here? Do you notice that? You will see often copies, right? 32, 32, 38, 38. This one doesn't. It's because there's no parallel line there, right? There's no parallel line anywhere there. Okay, let's do 22. Or, yeah, let's do it. Okay, so you see parallel lines. That's a really good, way to solve when you see. So basically, it's copies, right? Let's do one transversal at a time. Let's travel along this one here. What do you see along that one? I see a number and W, right? Okay. What are those called? Corresponding, right? That's what you wanted to say? You were thinking it, hopefully, right? One is outside, one is inside. They're on the same side of the transversal, corresponding. So W is the one I'm starting with, and that's 30 degrees, and I know that corresponding, no math. No math here. It's all you need to do is just tell me why you chose it to be 30. What else can I use here? Can I, so now these are all touching, right? And sometimes, this is where I'm going to tell you, I'm going to use a different pen. Try to bring up numbers even though I don't ask for them. Would you say that W and Z are vertically opposite? They look sort of, but they're not. Watch. I don't have more highlighters, but this line and this line, that's this angle here, right, is connected with these two. So this angle here would be vertically opposite to that one. Z is not. So that's how you verify. But look at what I'm going to do here. If this is 30, what do I know about this angle here? It's 30, vertically opposite. Beautiful, right? How's that going to help me? Oh, I missed one. X. Can you find X? What are these two? Alternate interior. Sorry, I missed that one. So why don't we do that one? That one is fairly easy to do. So I'll do that second. That's 110. Alternate interior angles are congruent. Done. So I actually put 110 here. What about Y? Y is fairly easy as well. They're right next to each other. So that's going to be my third option. So that's 70, right? And I will just use straight angle is equal to 180. And some of these keys are old, I know. So maybe if I said supplementary angles are 180, it's the same thing. Okay, I'm not going to take marks off if you use either or. Okay. So we've got this is 70. What should these add up to? They should add up to 180, and they do, so you're good, right? That's verifying you're doing things right. And what else? Y and Z. Y and Z are corresponding. Yes. So Y and Z are not corresponding in this case. I appreciate you saying it because I sometimes it's like, oh yeah, oh no, right? Like you gotta like say it. But Z is touching these two and Y is right touching these two lines. So if this had been Z, this whole thing here, then yes, they're corresponding. But Tia, you were saying find this.
No, if you find, like if you do 130, or if you do 180 minus 130 minus 110, find the angle opposite to Z.
Okay, find this one.
Vertically opposite to Z.
Mm-hmm.
And then 130 is alternate.
Yeah. So Tia is saying find this using sum of triangle. So what is this? Let's do some mental math here. This is 140, so 40. And then Z and 40 are vertically opposite. Mm-hmm. How else could you have done it? I was thinking along the same lines, there's a straight angle here, or there's a straight line here, so you could have technically said if this is 110, then this is 110 also here, like these two are corresponding. And then you already know that W is 30, right? So 30 and the 110, you subtract these two from 180 to get this one here. Because remember, this is a straight. So many ways to get there, of course. And I'll try to make the diagrams a little bit bigger on a test or a quiz so that you have room to kind of put stuff in there. Is that, I hope that helps. Okay, you can do it, guys. I know this is a little weird. You're not used to this. You're used to solving for X and sketching straight lines and finding the Y and the X intercept. That's coming. I like to leave that for later. I'd rather do these ones first, and then we're done to that kind of stuff that you're used to. All right, 23. How about 23? They're not easy. If I assign them, I don't know if you tried them. Now, maybe some of you didn't do them because you weren't sure. How about I give you a couple minutes to try this one on page 23 right now. Based on what I just did, try this question on page 23 and see how you do. I'll just do the attendance and then you have so many different shapes. After a while, once you've done a few, you're just gonna know what to do. All right? Okay, so follow along here, page 23. You'll get more practice, don't worry. How do you start here? Well, the key here is make sure you put these markings down. Which means, listen carefully, this shape here is called a parallelogram, right? So that means that you can use the 4 properties going this way, and you can use the 4 properties going this way. That's what that means. It gives you full license to go in any direction. Okay? So, which one do you start with? I would maybe start with X, because what do we know about these two here? They're parallel lines. This is technically the transversal that I'm using to go from one parallel to the other. These are CIAs, correct? Right? You see that? And so I'm going to start there. It doesn't matter what you did, but this would be 120. And I'll just say CIAs are equal to 180. For which one should I do next? I'll use the 25 here. This is touching one of the parallel lines. I'm traveling along this transversal to the other parallel line here. What do we call these here? AI, yeah. Alternate interior angles are congruent. So that's 25. Okay. Okay, what else? I could say, what's this here? This is 120, right? So if I don't ask you for it, but you think that's going to help you, just do it on the diagram, okay? Technically, what are these two here? Alternate interior, because these are my 2 parallel lines, right? They're alternate interior. So that if I asked you for it, you could have used that, or you could have used straight angle here. They're equal to 180 supplementary lines. So I can find W using what? Sum of triangle. But listen carefully, what else could I have done? What is 60 and this one right here? These ones are corresponding, correct? So if this is 60, then this whole thing should be 60 as well. So I could go 60 minus 25 to give me that. I'm going to use sum of triangle because I feel like that's what most of you probably gravitated towards. So I'm just going to go 180 minus 120 minus 25, that's 35. I use sum of triangle is equal to 180. Maybe I should stop overdoing it, right? Just give you one option, and if you figure out another option, this was my second, this is my third, and so this is the fourth. How do I find Z? Alternate interior, right? Because these two are parallel, I could travel and use this here. I could say that W is that one. Or you could have used, I just said, don't give me too many options, right? But there's a straight line right here. You know the 120, you know the Y, so you could just subtract those two from 180 to get Z, okay? So it's all good. So maybe the key is, doesn't have as many options as you'd like, but here we go, 180 minus 120 minus 25. You'll see that it's 35 as well, which is the same as W. Okay, so don't be scared, just write down what you think worked for you and then just go for it, okay? Next, the last one here. Well done. So there's three parallel lines. Remember, you're only going to pick one transversal at a time to connect them. Okay? I will travel along that one maybe. These ones are touching, so that one is fairly easy. This is 45, and it's just straight angle. There you go. So that's my first. And then I'm going to travel this way here. I'm going to somehow connect this W with, I could connect it with this, but I'm going to stick with this one. What are these two? Alternate interior. And a number of you are saying, when is it interior, when is it exterior? Think of the two parallel lines, okay? If you are inside of those two parallel lines, then you are interior, okay? So those are alternate interior. So I'm going to say W is 135. Alternate interior angles are congruent. There you go. And we're done on this side, correct? There's everything we needed to find along that one is done. Now I'm going to focus on this transversal here. Okay, that's my transversal number 2. What are these two here? Fairly easy, right? Alternate interior. Don't call it easy, Mr. Erickson. It's hurting my brain. Okay. There we go. And then with the Y, true or false, is 75 alternate interior to Z? False. Because Z is outside, right? If this is your parallel line right here, it's outside of it. So that would not be a correct answer there. What can we do here? The Y I know is 75. So let's find this one. This is going to be what? 105? Then I can use this one and this one. What are these two called? Corresponding. One inside, one outside. You know it's corresponding. So they're equal, correct? So I'm just going to say 105. And I use this property to verify that. Okay, so if there's something that I didn't ask for, make it show up here. If you just said corresponding, I would maybe not know what you tried to do there. Okay, so just feel free. I just like this for marking purposes. It's all in one place and in the same order. Otherwise, you would do X here, Y there. It's all over the place. It's a little harder to mark if you have it all over the place. Okay? You got this. You got this. Okay, let's go to 26 here real quick. I'm hoping this is review for you. I should have done this earlier, and some of you, group number 7 in that board, you kind of faced that issue. Scalene triangles, isosceles triangles, equilateral on page 26. Scalene, all angles are different. All sides are different. That's what a scalene triangle is. So if you wanted to sketch this, the markings on the triangle would be different. Okay, you would put a different marking on every side. And for angles, you would go 1 here, you'd go 2 here, and 3 there. So all angles would also be different. There's a relationship between the side length and the angles. Have you ever heard of that? Is this new? Anyways, isosceles. It's got 2 congruent angles, 2 congruent sides. Okay? If you have one known angle, you can find the rest. That's basically when you're in isosceles territory. So when these 2 sides are the same, what do you know about the angles across from them? They're also going to be the same. Remember this. Okay? So if this is 72, and you see, oh, and these 2 sides are the same, what do you know about this angle? 72, automatically, so I don't have to tell you that. So how would you find angle Y? We would just go 180 minus 2 times 72, correct? That's 144, so that'll be 36. Just like that, you figured out the... So could this be helpful in some cases, right? If you're doing these types of questions and I throw a triangle in there and you notice these markings, you're like, oh, if this is 72, then that's 72, right? And just remember, it's going to be on a bigger scale. What about this one here? If this is 50, then these are 50? No, that's not what I'm saying. These two sides are the same, correct? So you got to look across those two. And we know that this angle and that angle will be the same. So if I find angle E, I'm essentially finding angle F, which is going to be found by going 180 minus 50 divided by 2. There we go. So angle E is going to be 130 divided by 2, which is 65 degrees. And therefore, angle F is also 65. Like that goes without saying. But if you have an isosceles, I really only need to give you one angle and you can find all of them. Okay. Cool stuff. And your favorite, this is going to be your favorite, equilateral. All angles are congruent and all sides are congruent. Doesn't matter if it's a big triangle or a small triangle, it doesn't matter. If all three sides are the same, all three angles are going to be the same. Let's go A, B, C. What are all angles going to be equal to? They're adding up to 180. If you divide that by 3, you get 60, right? So guaranteed, as soon as you hear that equilateral triangle, or as soon as you see the markings, you can feel free to go 60, 60, 60. You're done. Like you've solved every single angle in that triangle. So you can see how this is going to be useful at times when that shows up. Okay. All right. I wanted to go polygons today, but I feel like I should do a little bit more of the practice involving triangles, what we've just done. Okay. I'm going to walk around. So as long as you work, I'm fine. Right? We're going to use some class time, and whatever we don't get done today, I'll assign for homework. We have about 20 minutes. So go to 27. You ready? Let me give you a little look into the future. No, I don't know what's going to happen in the future, but when we're dealing with polygons, we're going to be dealing with like pentagons, hexagons, and stuff like that. So I'm going to leave that for next week. You're welcome. It's everything is doable.
Wait, next week is actually was that next week?
It's not. I'm not 100% sure yet. I don't think it's going to be next week. There's going to be a quiz. Okay, go to 27. What is this? I'm just going to introduce the topic, okay? Number one, determine if segment AB is parallel to CD. Show your work. So you have to use one of the four: corresponding, alternate interior, exterior, congruent, consecutive interior. You're going to tell me whether or not lines are parallel. If they are, tell me why. If they're not, also tell me why. Okay, we know things. When lines are parallel, we know something about what we should observe regarding these four. These here are always going to be equal to each other if lines indeed are parallel. Consecutive interior, what does it add up to? 180. If this is not met, fail, right? It's not a parallel. They're not parallel, okay? You only need to show me one. You don't have to show me all four. I'll leave that to you. Let's go to 27. Go to 27, please. And then the bottom example here. what do you notice about, it's telling you that AB is parallel to CD. You can go and grab a marker maybe or something. AB is right here, CD is right there. So you do have the markings to confirm what this is saying. But what do you notice about the angle? 3-letter notation, right? Let's find, where is this one? Go find it, put your pencil on it. Yeah, just read it, honestly. Just start with A, go to C, and then go to D, right? And it's the one that, the smaller of the angles. Like, I mean, don't go outside here, right? We would never do that. You would want to go here. So this is it. If you want, you can put a 1 there and a 1 here, right? As you're finding them, where's this angle right here? BAD. B goes to A, goes to D. Which angle am I talking about there? This one. Put a little number 2 there, then go over to this and put a 2. So that's what I would suggest you do, so you're not mixing them all up. Okay, and then you're going to find the missing angles. So I'm going to go 27 all the way to 28, and 29 is solving for x. So I'm gonna do that as well. So page 27 to 29. That's your school/homework. And make sure you practice this. Ask me if you need help. I will first look for the key before I walk around. So if you use your phones, please just use them to look up the key, or you can listen to music. But don't let that be a distraction, all right? Here we go, guys. Friday.